Hello everyone. I take immense pleasure in walking you through our project Sign Language Detection. Firstly, we have imported a large number of modules: CSV, copy, ArcPass. CSV module is for accessing the different data informations, which is the labels which is associated with the models, and also for accessing the data and putting in more data as different entries, which is going to be like data points, and argpass modules for passing different command line arguments as inputs to this program when we are running it. It also runs on a default way, as we have set default values over here. So initially we are generating a capture object, video capture object, using the OpenCV2 library. Here we are setting the cap width and the cap height, which can be passed as input using the argpass module. And we are most importantly using media pipe implementation over here, which is actually a framework offered by Google for studying various like body pose estimation, hand alignment estimation, and so on, which can be quite complex task when we are using normal normal modules of image recognition and normal traditional algorithms like CNN or ANN. And we have two custom classifiers: the key point classifier and the point history classifier. Key point classifier for classifying the gestures right as itself. Point history classifier is a special type. Only if the pointer object is found, this point history classifier is invoked. And we also have a facility to measure the frames per second. And this is the method for drawing bounding boxes, where we use the bounding box function, which is a part of the OpenCV library, where it draws a box where all the points recorded are going to be lying inside it. Yeah, here it is, bounding rect. And this is for calculating the landmark list. uh, for Before that, actually, since the size of the frame is variable, it can be adjusted by the user as well as we can set it. It's not going to depend on the PC size. So we have actually used a relative style of finding the different points so that there is no error. That's why here, for finding the x and y coordinate, we are multiplying that relative coordinate along with the image width and the image height. And we're using deep copy over here, because we want to copy all the data from the particular image recursively. Each sub image is also taken care of. And this is where exactly we are going to uh, make the points relative. Pre-process point history. And this is an important function that we have used, which is draw landmarks. Generally, actually, MediaPipe itself offers a function that is like hand connections, which is going to connect all the different hand points together. But this function, draw landmarks, is user defined. If we can use this if we want those connections to be of one specific color or one specific type, and if we don't want all the points to be connected, it is possible to modify all that with this draw landmarks function. So each point in the hand is assigned a unique value. Each palm is assigned with 20 different values. Based on these points location, we can predict the gesture that a particular hand is pointing to. So this is what we have done. For example, let me take a small example. If I'm taking index 6, it is going to be index pip. If the index is 4, it is going to be thumb tip. On that part, I'm drawing a circle using OpenCV. The canvas that I'm using is the image, and the landmark 0 and landmark 1 mark the x and y coordinates. 8 is going to be the size. Then I'm specifying the color, which is 255, 255, 255, which means it's going to be white, complete brightness. And then I'm setting -1 so that it's going to be fill. This function is for drawing bounding boxes and writing text onto the screen so that it is rendered on the final object. And this is for calling back the main function. And we have used this because we don't want it if the landmarks does not exist, and just to make sure that we have no error in that case. And results.multi-hand landmarks is going to give us the different landmarks associated with that hand, which is going to be the x coordinate, y coordinate, and also the z coordinate. That is the distance from the camera and the hand. And multi-handedness is going to say whether the hand is a left hand or right hand. By zipping it together, we are making it into a single iterable so that we don't have two different objects to work with. As we can see, the camera object is functioning now. Using the FPS method, we can see the frames per second that is being shown over here. So now let's see how the model works. So if I keep my palms wide open, we can see it saying hello, because that's how we saved it. So yeah, it shows hello. If I close it, it says closed. Yeah, it's clear. Yeah. So if I show super sign, it says it's super. And the most important part is the pointer. It's going to follow wherever my finger goes. So, like at this point, the point classifier, that is the uh, key point classifier model, is going to get invoked. So, it is going to see in what way I'm moving my pointer hand. If I'm moving it like this, it is initially saying that it is moving. Actually, it should say moving in clockwise direction. Yeah, moving in. Hope it was visible. It came and it went. Okay, it was supposed to show in which direction it was moving as well, in clockwise direction and in counterclockwise direction. That was all that we managed to achieve using this particular project, this particular file. That's it. And we can turn off this window by pressing on Q or escape button. And yeah, this is where we are appending the point histories. And I also wanted to show something. After the draw landmarks, yeah, we have this thing, particular function, draw point history. If you would have noticed, the points, like when I was moving my pointer finger, the points associated, gradually they began to diminish. Initially they were big, slowly they began to diminish. That is because of this function. Here I have set I have set it to be 1 plus int of index divided by 2. That is the reason. So as time passes on, the size is going to be decreasing. It's the radius of the circle which is dynamic. Yeah, that's. We have also implemented a counter using MediaPipe, so it is going to count the number of fingers. Here, actually, we didn't use any custom-based machine learning model in the backend. So here, this is exactly what we did. We imported another module called from hand tracking module import find hands. So with this find hands module, it has a function which checks if different fingers are up or not, little finger up, then little finger and middle finger up. With these different functionalities, we can find what number that the person is currently showing. And the hand connections is also going to be done by this module itself. There is no need to do it separately by ourselves. So let's see how it works. So as you can see, I'm showing 4 and 4 is getting printed over here. One sec. Yeah. If I'm showing 2, yeah, 2 is getting printed. And if I show 3, 3 is getting printed. Shows that it is working quite fine. The final thing that we also did in this project is to controlling the volume of the system using hand signs. So we have imported a module actually called the PyCow module, which is used for controlling the volume in all Windows machines. And we have imported audio utilities, iAudio endpoint volume, and from C types we have imported cast and pointer. So C types is foreign function interface module in Python. So it allows Python to establish dynamic link with shared libraries. And this thing, comp types, we have imported this thing, CLSTX all. This particular module is actually a package for handling component object module objects, pretty much like all externally connected machinery and devices. So the audio output is also going to be considered the same way. And the get speakers function is used to obtain all the no it's going to obtain all the possible output volumes that are associated with a particular system, but it is going to take the default output of volume, which is going to be the speakers in this case. And in this, we have also imported the math module to find the hypotenuse between the 2 points. So, the distance is essentially calculated as the distance between the thumb and the pointer finger. Yeah, so it's given over here. The thumb is going to be point 4, the tip of the thumb, and the tip of the pointer is going to be at point 8. So, with that, we are going to do this calculation. Actually, as we can see, I have actually marked the various points associated. Point 0 is the wrist, 1 is over here, and this is point 4, and this is point 8. We are going to measure this distance between these 2 points. Based on this distance, the volume of the particular system is going to be adjusted. Greater the distance, greater is going to be the volume. And I'm going to circle both these points, and I'm also drawing the point line that is connecting both these points. And as you can see, we are actually finding the landmarks and drawing it by clicking this thing, mp hands dot hand connections. The media pipe is going to draw the hand connections by itself without us giving any input or any command. So this is how the default media pipe connection will look like in this particular program. We have not used any user defined functions for it. So I'm showing my hand and keep can vary this, and I'm getting the output how much it is. So you can see the system volume moving around. The greater and greater I stretch it, the more and more it goes. The lesser and lesser I put it together, it reduces. These are all the things that we managed to finish through this project. Thank you.